laptop says sign. Alright. Everyone hear me okay? Alright. So, my name is Droidcon. I'm from Facebook, New York. We have an office here, pretty big. I work on Android for experiences in Facebook and spend most of my time working on making newsfeed work seamlessly on your Android device. And this talk is basically going to be about all kinds of lessons we've learned over the last 2 years doing rendering newsfeed natively in Android. So, list views is basically what you're seeing a lot in your UI in Android. If you have an app, it usually has one of these screens where just like one big list view with endless items. That's how your SMS or Messenger app would look. And what the user constantly is doing is just scrolling to the next items in it one by one. And sometimes you are, however, if you do things a bit wrong, instead of scrolling smoothly like that, you get kind of like choppy scrolling. And if you keep doing things wrong, you get something like that. And you don't want that because that might kind of pass off on a slide, but when you're doing this and things don't move your finger on the device, it's a very bad experience. It actually drives people away from using your app. And what you want to be getting is this smooth scrolling. So what does it mean for it to be smooth? It basically means that you want 60 frames per second, so no one can notice any like choppiness. And if you want 60 frames per second, it's very basic math. We want to render one frame of this thing in under 16.7 milliseconds. Alright, so what does rendering under 16.7 milliseconds mean? It mostly means that we have our list adapter and it has this method getView, and that's where a lot of the things are being done while you scroll, and we need this method to be fast. GetView is the method that is being called every time a new item or new view is being scrolled into your list view. And how do you make that fast? So Android is really here to help us. Our main problem with making that fast would be that we do not want to inflate views while the user is scrolling. Inflating views is basically going to take all of our 17 milliseconds really easily. So what we have as a solution is view recycling that has existed since forever, and it basically means that when you scroll through your list view, Android getView method will give you back an old existing view. You don't have to inflate it, you just need to update some lines of text and an image. And this thing helps you quite a lot. Now you just need to do very little work preparing your getView, and everything is going well. And the problem with that is that this is kind of the small picture. Once you start going into a bigger app and more complicated app, you stumble upon a lot of new issues or things that you have to do in your getView. So, how does this manifest at Facebook? At Facebook, we have already a pretty big app, and we are stumbling upon all kinds of problems that should probably happen to every big enough app that has kind of a feed. And I'm going to go over a bit of our basic problem designing newsfeed to be have a fast growing experience. So our first issue is that unlike some Messenger or SMS app, each item in our list view is really big. It can contain several images, several bodies of text, it can contain an inline video and all kinds of things. And this thing has to be rendered in one frame under 17 milliseconds, or we're back to a choppy feed. And if that's not bad enough, it becomes even worse by the fact that we have many variations of stories. So we can have like a simple story with a photo in the middle, or we can have a story that doesn't have an attached photo with it, and then these two things look completely different. And we can have a version of a story that has an extra header on top of it. This is when you see a story of the form, John has commented on this, then we have like another piece of the story. And we also have cases where we render a different attachment. So if you share a link to a website, we render them preview of the website, and that has another body of text that we didn't have in the original story. We have even more complicated things like aggregated stories. If a few of your friends wish to do something for your birthday, we group all of this into one story that has multiple stories in it. And this is completely different than the original story. And we can also share stories where we get like a story in a story, which is also something you see on film. And this, along with a lot of other types of stories, makes things pretty complicated for us because we have so many variations and everything can go in everything and just have an exponential blow up. Another issue you come across is that if you start working on some sample app, at the beginning you're by yourself, it's very nice, you can do whatever you want. At some point you're kind of gonna have your team with you, and then you kind of need to watch out not to step on each other's toes. And as your app gets big, you get something like we have, which is over 100 developers committing monthly into the newsfeed code on Android. And honestly, it's not even the newsfeed code, it's actually the entire Android code base together. And then we get like 3 times more developers active on a monthly basis. And that means that all the small things we kind of don't really happen when 300 people have to cooperate. You just don't know. Another thing we have in Facebook, and anyone who's developing an app should probably follow that, is that we have constant iteration. We release a new version of the app every 2 weeks, and that means that when you start editing the code, it's a few weeks away from being at the user's hand, and we constantly add new features, remove all fake features, and so on, and it means that all of your code keeps on changing. So you can't just kind of, alright, I'm going to release this in 6 months, I have time to like fix and refactor and clean up. Everything goes out right away. And the last problem, which most people that develop for Android know, is that while you probably have a device similar to a Galaxy S4 and S5 right now in your hand, the median user has something that looks usually more like this. If you have a quad-core CPU, they have a dual-core CPU, sometimes they don't even have a dual-core CPU, the screens are smaller, they have less RAM, and all of these make it that this 17 milliseconds time effect that you have is actually can get you much less code running at the same time than what you would see on your Nexus or that. Alright, so these are basically our issues, and now we get to go back a little in time to 2012, and at that point the Facebook app was still mostly based on web views, and that we know at this point does not scale to a good enough experience, and we decided that it's time to switch newsfeed and render it to native Android code. So we're kind of going to go over a basic approach of what we've done initially. It was quite an intuitive approach, and then we'll see where does it fail and what we've changed about it. So our basic approach was based about custom views. If I want to display a newsfeed story, I will have a custom view extending some of the view classes like linear layout. It's going to be called newsfeed story view. It's pretty straightforward. And every small feature in it is also be a custom view. So I'm going to have a custom view for the header, a custom view for the main text body, a custom view that shows the attachments, photos, videos, music previews, whatever, and so and so. And the other aspect of this basic design was that each such custom view is going to have one important method that we call bind model. And what bind model does is basically takes some kind of object from your business domain, in this case like a newsfeed story, and breaks it on the view and to display it. So you have newsfeed story view taking a newsfeed story, and that in turn will call each part of it on its own bind model. So we take the story and pass it to the header view's bind model, and the header view will probably be at the top of this hierarchy, and we like take the title of the story, set that on the right text view, take the profile image URLs, and start an image request for that, and so on. And this is the basic approach. it's very straightforward, it makes sense, the code is where you expect it to be, and that can pretty much work when your app is small, but then we start running into problems. So the first problem is that recycling doesn't really work so well. If before you could just get the existing view, set a few things on it, and you'll get view with the FS method, now you're going to have a way bigger issue because your stories are so diverse and different that you cannot recycle and aggregate its story into a simple one. You can kind of start hiding and showing things, but at this point you're just missing the point of recycling. And because there's so many variations of this can be on, this can be off, you can kind of create a pool of what stories you expect, because there's a good chance that the exact structure of the story is just not going to repeat in the rest of your thing for quite a while. The second problem is that it's very limiting to how you can use your code. Once you have a class like newsfeed story view, and that class contains basically all the code of how to show a story, you find yourself that you need variations on that. So you suddenly extend your content, your newsfeed story view class, and have one to show this as a sub-story when you aggregate stuff, one to show this when you share stuff, and so on. And this is very bad for your code quality. This encourages you to take the base class, suddenly add some feature that only one of the subclasses need, and then you kind of see your code jumping back and forth from the subclass to the superclass, and kind of gives a vibe of spaghetti code. And again, you can avoid it and kind of refactor things and stuff like that. It's just that the design does not encourage you to do it. You only kind of start doing it after you see that thing that went bad, and you really don't want to be in that situation. The next problem that's kind of coming from the previous one as well is that when you use custom views, and put custom views in custom views and define all the hierarchies of your views, you get a very deep view hierarchy. So we can see here an example of how a simple newsfeed story used to look in a 3D representation of views being views, and it's quite a few layers deep. And first, this is going to destroy your performance, because the deeper the more complicated your view hierarchy is, the more time Android is going to be spending when it's laying out the hierarchy and measuring it. And that really builds up. And this is actually getting even worse for us, because what we see here is a simple story. But if I share a story, I actually take this entire hierarchy and put it again into the hierarchy of a story, and almost double the number of views that they have. And that is exceptionally bad, because all devices are just going to crash when you get to around an 18 bit views. And why would we get to 18? Because your list view is not going to be the first one, there's a few elements, then you have this story, then suddenly you have a special story in story, and your app crashes for some specific use case and you have to hunt it down. So that was also a bug, which kind of made us a few times go and try to reduce the view hierarchy back. Because naturally, again, it's the kind of problem that you only solve one kind of habit right, you don't solve naturally from the beginning. And the last problem we've had with this design is that it also limits when you can do all your heavy lifting. You have your bind model, and bind model is the place you are putting all your code that breaks your stories and headers and photos and stuff like that. The problem with bind model is that bind model is being called from get to view directly. So bind model has to be very fast. The bind model of a full aggregated story, you still want it to be below 17 milliseconds. And because this is the natural place to do things, you might originally try to just build your spannables that you need to show in the view in bind model. You don't want to do that, that's a heavy work. So what we had to do is implement all kinds of custom solutions on when to prefetch your images, not when you're scrolling, build your spannables in advance, and so on. But again, it's just requires custom solutions. We don't want that. It encourages every new developer who's writing a feature to say, I try to put everything in bind model, and when people are going to complain, I'm then gonna start adding my own custom solution on how we work around this problem. Alright, so this basically, after a while, it was working mostly nicely. You've been using Facebook most of you, I assume. But at the beginning of this year, we said we wanna fix a lot of these problems in a more systematic way. So we went with a new design for our USD code. And the basic premise was that even if we show you one story, there is no reason for that story to be one item in your list view. We can actually take your story that looks like one item and break it to several logical parts. This way your list view will show you a header part, then show you the text, then show you the attachment. And this looks the same when you look at it as a user, but it's so much better as a developer for us. So how would that work and why would it be better? Let's say we need to now build some standard story with a header, text, and footer. Then we no longer have to create a specific case for it. We just take the exact parts that we have and use them to combine our story. And this is good because we get recycling back. Now I just need to recycle a header with a header, and the header part always looks pretty similar to the next header. If I have two radically different headers, I'm just going to separate them and recycle each of them among themselves. And this also means we have way less use in memory. If before we had a few copies of the full story with everything that can kind of happen to it, try to solve it with use stubs and those kinds of things, now we just have the amount of views that we need. If you can see 3 headers on screen at once, we'll have 3 headers inflated in the list views recycling pool. If, however, it's something like a photo that we rarely can have both of those on screen, we're going to have just one. And that would going to improve our memory usage by a lot. So this basically would look something like this. In the old design, if I would have my news feed on this state, and on the right I can kind of see which views are currently being rendered by Android, and then I scroll a little, what would happen is that A, I have to now load the entire story in one frame, that story can be big, and I have to keep this entire story in memory as well. Well, in the new design, if I do the exact same scroll operation, I only have to load the header, which is way simpler to get in 70 milliseconds, and I can already dump a lot of parts of the previous story. I don't have to put 3 photos on screen. And this thing means that we get something very good. Now, our 17 millisecond mark only needs to be we only need to be able to put one part in it. We never get a huge aggregated story that there's no way to get in that time frame, especially on a typical Android device. Alright, so how do we get this thing working? If before, every standard this view, you have your adapter, and we had our newsfeed adapter, which is straightforward. Then now we're going to change it to be kind of an adapter of an adapter. It means it says every story now with several items in the list, we want to somehow logically combine this into one object, and that would be a unit adapter that manages all the rows in a specific story, and our list adapter has basically a list of these unit adapters. And how does the unit adapter look? The unit adapter has a list of some objects, and each of those objects is going to manage a specific row. And what are these objects? So, in the previous design, we always had our custom views, and the custom views had a find model method and so on. And we can't really store all the views for the list in the memory. What we want is to separate the custom view and all the business logic in it from the layout logic. So we do this by making a pretty simple, or what we call a down view. Our custom header view for now will have only very simple seller methods, and it's only kind of in charge of where the title go, where the subtitle go, and we can use it for several headers. And the other object is nicely called the binder, and what the binder does, it gets the logic that was in binder model. The binder can basically take a story, take the appropriate view type, and put this into one into each other. Alright, so the binder is the one in charge of taking the story figuring for the header, this is the title and subtitle, and I'm going to call the appropriate methods on the figure. And this means that now we can separate all of our binding logic from the layout logic. This is very nice when you kind of want to mix and match things. It's also much better when you want to write your unit tests, because you can kind of have an extra thing in your code that you can see that this acts as you expect, while the layout code is usually something you can't really unit test. Alright, so the binder, like a lot of Android objects, has its own nice life cycle, and basically you have your binder in the ready state, and once the correct item rolls into the viewport in your list view, the list view is going to find, we're going to find this bind, the right adapter, get it the right view, and then call bind. And bind is going to now switch your binder to the bound state. At this state, it is displaying some info on the view in the viewport, and when that thing goes out of the viewport, we have an unbind method, which is a good opportunity for you to do some cleanups. You don't necessarily have to do cleanups, but if you have some images or videos or stuff like that, you sometimes need to do some explicit. The last point with the binder is that we also have another bonus method, and that is called prepare. And the idea of prepare is that I don't want all the heavy work being done on bind. Bind is being called by the scroll. But I do want a natural place in my code to prepare everything. So if I need to build spannables, I can do those on prepare. And for each binder, prepare will be called only once before the first bind is called. And even better, you can intelligently schedule prepare on the UI thread. So we create all of our binders, and then we will try to wait for a time where you don't scroll and the UI thread is doing nothing, and then we're going to start allocating all the things. And in most cases, it actually works. We have such a time frame, and it means that we never have to start allocating things while you scroll, which causes way less garbage collections while you scroll, which is every garbage collection is basically going to make your list with shopping. Always go 70 seconds usually. So we have our custom views and we have our binders, and the one missing piece that we have here is how to get the right list of binders for the right story. Given a story, how do I know where I get my binders? How do I know this needs exactly a header binder, it needs a text binder, we have a photo attachment and a different attachment, and so on. And for that, we want a way to define, given a story, what parts it's going to have. So, for example, I want to define that I have a header binder and a header view. So for that, I have a class that is called part definition. And for every possible part of my story, I'm going to implement that interface. And that interface has two pretty straightforward methods, I think. The first one is get view type. Get view type saying, this part needs this type of view to display. And the view type class basically lets you do two things. A, actually create a view that matches this part definition. And also that gives us the recycling key. Because we want this view to be recycled, we want headers to be recycled with headers. So we want to be able to define when two views have the same recycling key, so that this view will know that they can be recycled together. The other method is the create binder method that takes whatever type of story or item you're trying to display and gives you the correct binder to display on that view. And that's basically it, only that once you have a lot of these parts, you kind of have to add one more thing. So you actually have a single part definition, which is what we discussed, and you want a way to be able to group several part definitions together. And the reason you want to do this is just because it makes things logically better, or you need to do more complicated stuff. Let's say we have this section in the story where we have the attachments, whether it's a photo or video or something like that. We want to be able to group all of these attachments into one section that will figure out what kind of specific attachment it has and find the right single part definition. The one last thing in this hierarchy is that we have a super class called part definition, and it has an isNeeded method is needed is basically just a performance optimization. It's a fast, lightweight way. It's a fast and lightweight way for us to say, oh, this story is going to need this part. And the reason for that is that we're going to have a huge list of parts, and we want to be able very fast and without allocating to say, all right, this is not needed for this story. There's no need to create binders and start allocating stuff like that. So this is basically a fast guard statement for stories. So how does this thing work in practice? And let's say we have our simplest story and we want to create a unit adapter for it. We'll have one main group power definition, which is called basic group power definition. And when we want to build the unit adapter, we just don't start recursively working our way through the hierarchy of the power definitions. And we'll go and look at basic group, we'll get all its children and figure out that these are the children the basic group has. And then we're gonna go one by one on each of these parts and check if it's needed for our story. If it's needed and it's a single part definition, we create that binder and put it in the list of binders. And if it's a group, we go into its children again and again. And the end result is a list of binders of all the parts we need. And this also shows like how this solves our original problem of having a deep hierarchy. We now still have a very deep hierarchy of our definitions, but this does not translate into an aggregated story that would be stories inside stories. Now we have power definitions inside power definitions, but the proper list in the end of the binder is just one flattened list. No matter how deep you are in the hierarchy as the attachment of a sub-story, you're still going to be a top-level view in your list. So this reduced our view hierarchy deep by quite a few, and we basically don't get these crashes anymore. And thing of the past. Alright, so kind of in a nutshell to sum up what basically goes in the newsfeed, those three things that you kind of just need to do to get this working. Whenever a notified dataset chain is called, you want to generate all the unit adapters for your objects, and you do this by getting the right root power definition and recursively generating the binders. And then you want to start scheduling prepare in whatever time you have. Whenever get view is called, we just have to go find the correct unit adapter, find the correct binder in that, for that row, and call bind. And when you have a recycling, your recycling callback, we're kind of going to do the opposite. Find the correct binder and call on. And that's pretty much all of it. And alright. So what is this gas and what is this gas? So the main issue is this is so much nicer to maintain. We have right now more than 240 different part definitions in the code. This is the result of having several types of feed and new features that are gradual that we check and test them, or things that sometimes only an employee can see. And we have all of those together. We just can't just like roll them in views. But when you have part definition, it works very nicely. If I want to add a new part into a story, I work in my own file. I have one connection point to say which child of what I am. I have a very fast is needed method that means that no one of our hundreds of millions of users is actually going to suffer in performance because of something that it doesn't see. And overall, this seems to hold up pretty well in that regard. And the next thing is that this improves your scroll performance. If before you would scroll in usually in an older phone and see that there's like hiccups in your scrolling when a huge or big story is going in, now it's way more our max frame time is down because our main problems are just the most complicated part we can have. It's a video or maybe some ads we still haven't converted completely, but those problems have been basically removed by that. We even removed them more by doing the prepare methods. So things that would need a lot of like setting URLs and starting image requests that would happen during scroll are now only happening during scroll if you basically do this very fast and don't want to be configured at all. Which you should. It's nice. And we've already reduced views and stuff we already made. We have our memory usage is down. This took our out of memory errors down by more than 15% for user, which was a very big win on that regard. And like every design you have, it has a few downsides. So first, if you have a simple feed, this would be like extreme over-engineering of your product. If you're not gonna be doing a messaging app, or if you have like the exact same type like Instagram has, you should probably not go all the way for that. This is good when you actually have a lot of developers and your story type constantly changes from one item to another, and you can actually gain stuff from it. So it's very good if you have a complicated field. I recommend it. Otherwise you can kind of wait with it. There's things you can still take from it, like the binders and the prepare methods are still probably going to work and get you better performance. Actually breaking into rows is more important if you actually have really good stories. And another downside of this design is you're going to have a harder time doing interactions that involve a few parts. So for example, if you like a story in Facebook, you'd see like the like icon pop up, and then the comment, the number of likes about it pop out. And these things become harder to do because they're now, each of the parts has its own binders, and you actually have to kind of communicate between the two binders, and that requires more work, usually by sending events, where before that you kind of have it all in the same object. So that's another downside of this design. And that is pretty much it. And we are left with time for questions. Yeah.
How do you figure out when to schedule the prepare methods?
So I think we went through a few iterations. The first one was if the list view is not scrolling to it. This is not good enough because people love to hold their finger on the list view sometimes. So we've improved it and basically built a choreographer class that kind of takes a few things into account, checks, like tries to schedule things on the UI thread and see how fast they go back and stuff like that. But we kind of hoped in the beginning that there will be like that Android is going to help you with that, but I forgot the name of the feature. But doing the delayed doing the idle handlers in Android, they do not do what you want. They basically, you can like look at the code and see that they will basically constantly run while you're scrolling. Because if they see there's no message for like to be executed right now, but the next message is delayed by 1 millisecond, then they assume this is a great time to run it while I So this unfortunately does not work. You have to like do a few clicks and run it nice. Yeah.
Do you have any optimizations, like when to update the API, and update the data model as you're scrolling?
So we have a few things like that. They're mostly done for animations, so not like suddenly do a notify data set change all the animation. But what we've done in this case is mostly instead of regenerating all the binders, we kind of try to smartly guess and do a diff of what binders need to be updated. So if you just like scroll down and we load a few more stories, we aren't really gonna regenerate all the binders because that can become an issue if you scroll too much down. So we've added like an extra optimization where we kind of say like, all right, these all have not changed, and new binders. Yeah.
So is this code available to have like a sample app that demonstrates this design?
No, but it's on Facebook. There's no open source. Maybe when we get it like post-dated and convert it to all of our apps. Yeah.
Is your point information hierarchy kind of hard-coded in the app, or do you have that like database that can be kind of dynamically changed or update that?
It's hard-coded in the app right now because there are just way too many cases. Like for one thing, like every part definition is going to have a piece of code for it is needed, and is needed is basically just general code, and the binder is just general code. We have like some nice designs on how to like in a nicer way like create part definitions that are kind of similar to a different one, stuff like that. Try to avoid common pitfalls, but in the end it's just like a piece of code that you can go through and say like, oh, this part is this part does that.
So then when you were citing kind of the okay, the Facebook employee might see different fields or whatnot, that intelligence is also in the app, or is that
things are usually in there. But don't go, they don't have exciting stuff. I wouldn't decompile it, it's not fun.
So last question.
Yeah.
So how is the interaction like with the design itself? Like, I'm sure they might come up with new stories all the time. Does that become like a workflow? Okay, we have to now modify the part definition hierarchy and push it out, or is it more of a structured kind of thing?
So it comes from all over the places, the design changes. If it's basically just like putting a part in, that's a very easy thing. Like basically one developer can come, just add his part, put it in the right place in the hierarchy. We don't just release things, we like first test this on a fraction user and you can just launch it within like 2 weeks, that's it. If we have bigger design changes, then these are like always more complicated. Like if you want to like change the background of everything, then there's a few other abstractions and encapsulation to let you do it in a nicer way, but they're basically separate from the design. Yeah.
So I didn't catch, are you using recycler view or list view then?
We were using list views, and we used our own custom recycling for way before those things kind of existed. And we still have a lot of those things, but most of them we moved, but we're just using the basic list view. But a custom list view.
Are you interested in the recycler view?
I haven't looked at it yet. It sounded nice. There's things I like kind of looked and I don't like the view order pattern. I think it's like extremely unintuitive. The first time you see it, like, what's a view order? Why do I have it? It doesn't really convey to you what's supposed to happen. This is why I like the binders, that it kind of conveys to you, oh, there's a prepare step. You're naturally gonna, without understanding, attracted to prepare your stuff here instead of doing stuff like that. Yeah.
Did you explore custom composite views at all to reduce your layer hierarchy?
Yes, we have a few of those, and it's I think what a lot of our apps are doing. And the main reason it's not as useful for us is because of the constant like editing. So if you go for like complex custom views, you're gonna have a lot of maintenance bugs. We try like we have putting an image next to a text, and this thing is gonna break on our right to left language. This thing is gonna break in our case and stuff like that. And when you constantly want people to like add new parts, remove parts, change that, you don't want them to go for like custom view, too many complicated custom drawers and stuff like that. So this is why we went with this approach. It really like favors like the developer velocity compared to